This is part 2 of the crude oil and fuels topic. This is AQA GCSE chemistry, and it's valid for dual and triple award students. As always, I'm going to recommend you pause, try the activities as you go. In this video, we're going to focus on fractional distillation. There's a lot of new key terms if this is your first time, or a lot of key terms to revise if you're going back over this. Let's start with that actually and think about what these 4 words mean in the context of fractional distillation and crude oil. So, volatility is how easily something turns into a gas. If something is more volatile, it becomes a gas much more easily. Viscosity is about how easily something flows. If something is more viscous, it's thicker, it's gloopier, it flows less easily. Flammability is how easily something ignites. So if something's more flammable, it ignites more easily. And boiling point is the temperature at which a substance boils or condenses. Perhaps the one that people know far more commonly anyway, out of the 4. So a question for you here. And this does link back to what we've looked at in the bonding topic as well. And longer chains do have higher boiling points. Now, the reason for that, there's a term that we use quite sparingly in the bonding topic. It's because longer molecules have stronger intermolecular forces, and that means more energy is needed to overcome them. If that's something you're a bit rusty on, go back to the bonding topic and look at covalent bonds and simple covalent molecules again, because it is important. Just to summarise some of the key ideas that we've seen there, as the molecule gets bigger, the boiling point gets higher. As the boiling point gets higher, things become less volatile. That makes sense because you wouldn't expect something to become a gas easily if it has a high boiling point. As the boiling point increases and size of molecule increases, so does viscosity, but flammability actually decreases for longer molecules. And actually, when we burn petrol, for example, petrol becomes a vapour in the car engine before we ignite it. So if you think about it in those terms, shorter chains that are more volatile are more flammable, which perhaps makes them more suitable as fuels. Before we move on to fractional distillation, it's good to remind ourselves what distillation is. We've got the diagram here with the Liebig condenser. What actually is the process? Well, what we have is evaporation, and that's followed by condensation. And that's it in a nutshell. You've got your condenser, the water going in, the water going out, and that will cool the vapour in here, so it will come out condensed as a liquid. But we evaporate, it rises up, the liquid is shifted, or the vapour, is forced down into the condenser where it's cooled and condensed, and then it comes out of the end as a liquid. So, fractional distillation is a process which allows us to separate crude oil into different fractions. In terms of molecule size, what would we say about molecules within a fraction of crude oil? Well, they're not the same. It's actually a range of hydrocarbons of similar length, of similar size. So that's a really important distinction to make. Within a fraction, we have similar molecules from the crude oil. And in terms of their boiling points, that also means, because boiling point is partly determined by chain length, the boiling points within a fraction are similar. So what we're going to do now is try to take a look at how fractional distillation works. This is possibly good to watch in conjunction with the bite size information, so that you can look at it on there and then maybe come back and have a go at answering this. But this is trying to bring the whole of fractional distillation into some simple structured sentences that will make sense. So what order would you put these in? Well, the logical place to start is that crude oil is heated and passed into the column as hot vapour. I've then said that the column is hotter at the bottom and cooler at the top. That's often a marking point on its own. Now from there, I have gone to the fact that the larger molecules do not evaporate, they stay as liquids at the bottom. The larger molecules might go into things like bitumen or candle wax, and that is important to remember. But the others do vaporise, and they move up the column where, as the column gets cooler, they will cool also. And the shorter chains, with lower boiling points, will go higher up the column before they condense. So what we've actually got here is lots of different fractions with similar boiling points being separated, removed from different levels within the fractionating column, where they can then be used effectively. And that's things like petrol and kerosene and diesel and fuel oil, etc. Now we're going to look at this in a different way. I'm going to look at a series of answers that students have given, and we're going to see whether we think that the answers that are given are sufficient. See what your thoughts are. Well, in this one, there's really no detail at all, so we're not going to get any marks on that one. Let's look at answer number 2. So we have got here that the crude oil is heated, not told it's vaporised. We're told it rises up the column and then condenses, but it doesn't give us an idea of the temperature gradient within the fractionating column. It doesn't give us an idea about shorter chains condensing higher up. So there's very limited detail here. You need 4 separate points. That would possibly get 1 mark. Next one. If you did read all of that, I admire your level of effort and your will. This does happen. People write far too much and it's not needed. The correct answers are in there, but that's time that could have been spent on other questions. It's far too much detail. So let's now look at the final answer. Well, we've got the idea that it's vaporised and passed into the column. We're told about the temperature gradient. We are told that the hot vapours rise up, cool, and condense, and we also see that shorter chains condense higher up the column. It's pretty concise, it's got lots of good information. That's the sort of thing that we are aiming for. That takes us to the end of this video. Thank you for listening, and goodbye.